In April 2001, a supervisor arrived at the thermal processing room of a food flavors manufacturing facility and started the production run together with a production technician. 1.5 hours later, the supervisor loaded the ingredients into the thermal reactor. He raised the temperature of the reactor to 120 degrees Celsius and maintained it for 15 minutes. When the reactor temperature fell to 70 degrees Celsius, the production technician proceeded to discharge the product from the reactor to the fermenter for storage. After 15 minutes of discharging, the production technician opened the cover of the reactor to inspect the interior and check for leftover products. He saw some leftover salt at the bottom of the reactor and decided to pump the product from the fermenter back to the reactor again in order to drain away the salt residue. This draining process was repeated 2 to 3 times. The production technician and supervisor inspected the interior again, but saw some black residue at the bottom of the reactor. The supervisor carried out the first wash from the outside of the reactor by flushing the interior with hot water, followed by the second wash with cold water. However, the black residue remained. A plant washer was called in and instructed to clean the interior of the reactor, as the black residue would contaminate the next batch of products. When the plant washer arrived at the thermal processing room, he carried out the washing immediately. He first sprayed the interior of the reactor with water using a hydrojet gun. As the residue remained after hydrojetting, the plant washer stretched into the reactor to see if he could brush away the black marks. After a while, he withdrew from the reactor, complaining of a strong smell inside. The production technician handed him a paper mask. The plant washer wore the paper mask and stretched into the reactor again. After a short while, he withdrew and sat at the mouth of the reactor, gesturing that he could not stand the strong smell. Suddenly, he slipped and fell into the reactor. The supervisor looked into the reactor and saw that the plant washer was unconscious. The supervisor then stretched into the reactor to try and rescue the plant washer. He slapped him a few times to try and revive him, but the plant washer did not respond. Shortly after, the supervisor had difficulty breathing and attempted to withdraw himself from the reactor. However, he blacked out as he was on his way out. The supervisor was subsequently pulled out of the reactor by the flavor technician and his colleagues. Nobody knew that the plant washer was still unconscious inside the reactor until the production technician alerted them. The flavor technician then stretched into the reactor to rescue him. However, after a few seconds, he withdrew from the reactor because of breathing difficulties and asked for a cartridge respirator. After wearing the respirator, he stretched into the reactor again and pulled out the plant washer with the help of his colleagues. This reactor washing operation resulted in the death of 1 worker and injured 2 others. What went wrong? Reactor not identified as a confined space. Management failed to recognize that reactor inspection involved head entry into a confined space. It was therefore overlooked that confined space entry was a necessary step of the reactor washing operation. Confined space entry procedures not established. Management knew that head entry was often required but did not institute a permit to work system for reactor washing operation. Presence of toxic gases undetected. Management failed to identify that hydrogen sulfide and other sulfide compounds could be generated during product manufacture under abnormally high temperature conditions. No safe work procedures for non-routine work. Only a cleaning checklist for routine work was available. Workers were not given special instructions on how to remove the residual black marks that remained after hydrojetting. Lack of training. The plant washer was not trained for confined space work, and no confined space attendant was appointed to keep watch. No proper breathing apparatus. A paper face mask was worn by the deceased worker instead of an air-purifying respirator. Lessons learned. Risk assessment. Before starting any work in a confined space, always conduct a risk assessment to identify safety and health hazards. Measures to minimize risks should be implemented before starting work. Identification of a confined space. Management should carry out a walkabout together with workplace safety and health professionals to identify, document, and label all confined spaces where workers may be required to enter during the course of their work. Confined space entry permit system. It is important to recognize that confined space entry occurs once a person's head passes through the opening of a confined space. Confined space entry procedures and a permit to work system for entry into a confined space should be developed and implemented for all such situations. Mechanical ventilation. Mechanical ventilation should be used to ensure that the atmosphere within the confined space is safe for entry. Gas testing. Checks on oxygen levels and presence of flammable and toxic gases should be conducted prior to entry and repeated at regular intervals after entry to confirm that the atmosphere remains safe for continued work. Safe work procedures for non-routine work. Safe work procedures should be developed and implemented for both routine and non-routine work. This will ensure the reactor washing operation can be carried out safely without endangering the safety of the workers and others in the vicinity. Safety training. It is important for workers who carry out reactor cleaning to be properly trained and fully aware of on-the-job hazards. It is also necessary for them to undergo training on confined space entry procedures and proper use of personal protective equipment prior to the reactor washing operation. Suitable breathing apparatus. Workers must be provided with suitable breathing apparatus before entry into any confined space where toxic gases are present. In particular, the use of suitable breathing apparatus is very important for workers undertaking rescue operations prior to entry into a hazardous atmosphere.